When a lighting contactor coil repeatedly burns out and the accessory terminal block shows damage, several factors should be investigated. Addressing these issues systematically can help prevent future failures. Focusing first on the contactor coil, overcurrent is a prime suspect. The coil may be overloaded if the lighting circuits draw excessive current. To check this, verify the wiring and load on each circuit, making sure they do not exceed 20 amps per circuit. Use a clamp meter to measure the current on each circuit while the lights are operating. Secondly, voltage fluctuations can also damage the coil. Severe voltage spikes or drops can stress the coil beyond its design limits. Ensure the power supply is stable and within the specified range for the contactor, typically 120 volts. You can use a multimeter to measure the voltage at the coil terminals. Thirdly, debris or contamination can contribute to coil failure. Dust, debris, or moisture accumulating inside the contactor can cause shorts or arcing. Regularly inspect and clean the contactor to prevent such issues. Use a vacuum or compressed air to remove any accumulated particles. Fourthly, loose connections can generate heat. Poor electrical connections at the coil terminals or within the contactor can lead to heat buildup and subsequent coil damage. Tighten all connections securely, ensuring proper contact. Use a torque screwdriver to tighten screws to the manufacturer's specifications. Fifth, the contactor itself could be defective. If all other causes are ruled out, the contactor might have an internal defect. Contact the manufacturer for testing or replacement. Provide them with details about the repeated failures and the specific model of the contactor. Moving on to the accessory terminal block damage, several factors can contribute to its failure. Overvoltage is a common cause. The terminal block may have been subjected to a voltage surge or spike. Check the power supply and consider installing a surge protector to mitigate future surges. A surge protector should be installed at the main electrical panel to protect all connected devices. Secondly, overcurrent can also damage the terminal block. High current flowing through the block could cause it to overheat and damage its circuitry. Review the wiring and load in the connected devices, ensuring they are within the block's rated capacity. Refer to the terminal block specifications to determine its maximum current rating. Thirdly, mismatched devices can lead to problems. Ensure that the devices connected to the accessory terminal block are compatible with the contactor and its voltage rating. Incompatible devices can draw excessive current or create voltage imbalances. Fourthly, external damage can cause failure. Physical damage to the terminal block, such as impacts or exposure to moisture, could have caused its failure. Inspect the block for any signs of physical damage. Now let's outline the troubleshooting steps in more detail. Firstly, inspect the wiring thoroughly. Check all wiring connections for tightness, damage, and proper gauge. Loose or damaged wires can cause arcing, overheating, and voltage drops. Replace any damaged wires and ensure all connections are tight and secure. Secondly, measure the current draw on each lighting circuit. Use a clamp meter to measure the current draw on each lighting circuit while the lights are operating. Ensure it does not exceed 20 amps per circuit. If the current exceeds 20 amps, reduce the load or redistribute the circuits. Thirdly, check the voltage at the contactor coil terminals. Use a multimeter to measure the voltage at the contactor coil terminals while the contactor is energized. Ensure it is within the specified range for the contactor, typically 120 volts plus or minus 10%. Fourthly, examine the contactor closely. Inspect the contactor for any visible signs of damage, burning, or arcing. These signs indicate internal problems that require replacement. Fifth, if installed, test the surge protector. Ensure the surge protector is functioning properly by using a surge protector tester. These testers can simulate voltage surges and verify the protector's response. If you are unfamiliar with surge protector testing, consult an electrician. To provide more comprehensive guidance, consider these additional aspects. Start by thoroughly documenting the existing setup. Before making any changes, document the wiring configuration, the types of lights being controlled, and any other connected devices. This documentation will be invaluable for troubleshooting and future maintenance. Next, examine the load characteristics of the lighting circuits. Are you using LED, fluorescent, or incandescent lights? LED lights typically draw less current than incandescent lights, but it's essential to verify the actual current draw for each type. Fluorescent lights may have a higher inrush current when they are first turned on, which can stress the contactor coil. Also, consider the ambient temperature. High ambient temperatures can reduce the current carrying capacity of wires and increase the operating temperature of the contactor. Ensure the contactor is installed in a well-ventilated area to prevent overheating. Next, investigate the motion sensor. A faulty motion sensor could be sending erratic signals to the contactor, causing it to switch on and off rapidly. This rapid cycling can overheat the coil and shorten its lifespan. Test the motion sensor to ensure it is functioning correctly. Consider replacing it if it is suspected to be faulty. Next, check the control wiring between the motion sensor and the contactor. Ensure the wiring is properly sized and shielded to prevent interference. Use shielded cable if the wiring runs near sources of electromagnetic interference. Also, consider the age of the components. If the contactor, motion sensor, or other components are several years old, they may be nearing the end of their lifespan. Replacing aging components can improve reliability and prevent future failures. Next, ensure proper grounding. Proper grounding is essential for preventing electrical faults and ensuring safety. Verify that all components are properly grounded according to local electrical codes. Improper grounding can lead to voltage fluctuations and equipment damage. Next, evaluate the power quality at the site. Power quality issues such as voltage sags, swells, and harmonics can damage electrical equipment. Consider installing a power quality monitor to identify and address any power quality problems. Work with a qualified electrician to interpret the monitor's data. Also, check for any recent electrical work in the area. Construction or utility work nearby could be causing voltage fluctuations or power surges. Contact the utility company to inquire about any recent or planned work that could affect power quality. Next, inspect the contactor enclosure. Ensure the contactor is installed in a suitable enclosure that protects it from moisture, dust, and physical damage. The enclosure should be rated for the environmental conditions in the installation location. Next, consider using a solid-state contactor. Solid-state contactors have no moving parts and are more reliable than traditional electromechanical contactors. They are also less susceptible to voltage fluctuations and other power quality issues. If replacing the contactor, consider upgrading to a solid-state model. Finally, document all troubleshooting steps and findings. Keep a detailed record of all tests, measurements, and repairs performed. This documentation will be helpful for future troubleshooting and maintenance. If you are uncomfortable performing any of these troubleshooting steps, or if you cannot identify or resolve the issue, contact a qualified electrician for professional assistance. Working with electricity can be dangerous, and it is always best to err on the side of safety. Remember, electrical work should always comply with the National Electrical Code, or NEC, and any local electrical codes. Always to energize circuits before working on them and use appropriate personal protective equipment such as insulated gloves and safety glasses. When measuring current, use a clamp meter that is properly rated for the voltage and current levels in the circuit. Never exceed the meter's maximum ratings. When measuring voltage, use a multimeter that is properly calibrated and in good working condition. Be careful not to touch any exposed conductors while measuring voltage. If you suspect a voltage surge, consider using a surge protector tester to verify its proper operation. Never attempt to repair a damaged surge protector. Replace it with a new one. When replacing a contactor, be sure to choose a replacement that is rated for the same voltage and current as the original. Consult the manufacturer's specifications to ensure proper compatibility. Always follow the manufacturer's instructions when installing and wiring the contactor. Double-check all connections to ensure they are tight and secure. When working with wiring, use properly sized conductors and connectors. Refer to the NEC for guidance on conductor sizing and ampacity. Always use insulated tools when working with electrical circuits. This will help prevent accidental shorts and electric shocks. When working in damp or wet locations, use ground fault circuit interrupters or GFCIs to protect against electric shock. GFCIs can detect small current leaks and quickly shut off the power to the circuit. Before energizing a circuit after completing repairs, double-check all wiring and connections. Make sure all covers and enclosures are properly installed. Use a non-contact voltage tester to verify that the circuit is de-energized before working on it. This will help prevent accidental electric shocks. If you are unsure about any aspect of electrical work, consult a qualified electrician. It is always better to be safe than sorry. By following these guidelines, you can effectively troubleshoot and resolve lighting contactor coil burnout issues and accessory terminal block damage, ensuring a safe and reliable electrical system.